welcome to Eugene Science Center's program, Next Gen STEM. I have with me our Innovator of the Week. She has been working in space industry, or in the space industry since 1995. What started as a desire to be an astronaut grew into a love of space science, engineering, and the search for life. So it's my honor to introduce our Next Gen STEM Innovator, space science educator, Dana Bolles. Dana, thank you so much for joining us today.
Hi, Elena. Thank you.
Yeah. All right. So we've got some fun questions. So first off, what inspired you to work in space?
I love the fact that people want to explore space. I think it's really fascinating. I always loved all the science fiction shows growing up. And so thinking about a career, I thought, I want to be part of that. I want to be part of our exploration of space.
Yeah, that's awesome. And what are a few different jobs someone could do in working in space science?
A lot of the jobs are engineering or science. And so on the engineering side, you would have stuff like robotics, like the rovers that we have on Mars right now. You could also work in materials science, so looking at what sorts of materials would work well in the environment of space, and also computers, right? Because everything is controlled by computers. Mm-hmm. And of course, telecommunications, because you need to be able to communicate with the rover or the spacecraft or what have you. As far as space scientists, there's stuff like astrophysicists, and these are astronomers who study celestial things like black holes and asteroids and exoplanets, which are planets outside of our solar system. There's also biologists who look at how microgravity and going out in space affects the body and different living organisms, even plants. And then there's atmospheric scientists and meteorologists, which study the weather on Earth and the climate.
Awesome. Yeah, there's a lot of different elements of.
There are. You can get involved in almost any way, really.
Yeah, and what drew you into engineering, and what was your college experience like studying that?
I think initially what drew me to engineering, there was a few things. I have a very visible disability, and I rely on equipment to be dependent. So I have a wheelchair, I have artificial arms, which I'm not wearing right now, but I have them when I need them. Mm-hmm. And I drive a vehicle with hand controls. So realizing at a young age that I depend on this equipment to be independent, I thought, well, being an engineer, or mechanical engineering in particular, would be helpful, right? Because I thought it would teach me how to think, so that if I couldn't find the equipment I need, whether it existed or whether I don't know how to find it, then I thought, well, maybe I could design it. Maybe it could teach me how to think so that I can make these things to help me. And it was a good fit. The thinking like an engineer helps a lot in my daily living. And as far as college experience, I loved going to college. It was really hard. Engineering is not one of the more simple majors, but it was worth it. And it was actually in college that I began to see the true value of working in teams. So I had, in everything from studying with friends to being on projects, working in the lab with partners, and then also I had a senior design project where I was on a design team with two of my friends. So, and actually what's kind of interesting is that value of teamwork also, I saw it's important in the workplace. So it was a really good learning and stepping stone into having a real job.
Yeah, that's awesome. So in this technology that you mentioned, how does technology used in space exploration help people here on Earth? Because space agencies do more than just look outside of Earth. Is that right?
Right. Yeah. And, space technology, it's funny because although when we're designing stuff for space, we're making sure that it meets the rugged requirements of being in that environment, but there's also concepts and purposes of that equipment that could be helpful here. And so one example would be technology and cameras. Mm-hmm. So here we are sending satellites, and we're sending rovers and everything to different planets, and they need to be able to send back clear enough pictures so we can get the value from that, right? But that also could be applied to our cameras here. And look at our phones. Our phones have amazing technology in it. And, definitely some of that technology has helped to bring that along. And another example would be the spacesuits the astronauts use. They have to help regulate the body temperature of the astronauts, but there's also applications here on Earth where some people they run a little hot, like I do. They run a little hot with their body temperature. So it helps to have garments that help them to be able to release that heat. And so some of our technologies also help with that.
That's awesome. That's so versatile. I love it.
Mm-hmm.
So one technology and feature that a lot of people think when they think of space science are satellites. So in a brief explanation, how do satellites work and how are they used in space science?
A satellite, so basically all satellites have two things in common. They have an antenna and they have a power source. And so a lot of the satellite, like we have a lot of satellites looking back at Earth, and so we put them in orbit around the Earth, and then they look back, and a lot of them do is they take pictures, and what's helpful is they could take pictures of really large areas, and that's helpful when you're looking at stuff like weather and you're looking at how things change over time with the lands and the water and all that. Also, there's communication satellites. So those are helpful with our phones and our TVs and internet and stuff like that.
Yeah, very cool. So in starting your career in space education, what is the first project that you worked on that you were most proud of?
Let me see. I would say one of the first ones I worked on was on TDRS, the Tracking Data and Relay System satellite. And why I was so proud of that is because it's one of my first projects I had when I started out as an engineer. And so it was really scary for me, right? Because I left home, I went to another state, I didn't know anybody, and here I am in this work environment doing this engineering job, and it was really stressful and scary, but it felt good being able to manage that payload and be successful at it. So I've done a lot of things over the 25 years, but that's just one of the ones that I thought was special because it was in the beginning.
Yeah, no, that sounds awesome. And what would you say is the coolest part of your job?
The coolest part of my job, it's the people I work with. I'm coming to work and I'm working with the best and the brightest people, and here we are, we're all focused on the challenges of space exploration, and that's just a really exciting thing to be talking about.
Yeah, that sounds great. So you had kind of mentioned that in college you definitely worked with teams. Now do you work by yourself or with a team? And if so, what other STEM disciplines make up your team or work environment?
I do work with a team right now. The disciplines that make up the team, and I think I'm catching them all, but we have computer programmers, we have engineering, and scientists.
Awesome. So in moving towards the search for life beyond Earth, we had a fun audience question. Do you think aliens are real? And if so, what would they look like?
I definitely believe aliens are real, and that's my personal belief. I do, knowing what I know about working in my agency or at the agency is, I think it's going to be more like microbial life, so it's not going to really look like us. Whether that exists, I mean, honestly, I do feel like it does somewhere out there, but the universe is so vast. The chances of us finding it, I think it's just really slim. But I can't believe that we're the only ones of the whole universe.
Yeah, there is a lot out there. And for those that may not know, how would you describe microbial life?
Just very simple puddle of something. I mean, I wouldn't. Some people describe these things as snotties that are like hanging like in caves and all that. Like it's really kind of gross looking, and so that's what I would think would be out there possibly. Be careful, don't step in it. You don't want to step in it.
And what is your job currently at your space agency?
Currently, I lead a team of web developers and editors for our website. So communicating to the public.
Awesome. Yeah, space education is great. We love to learn it as the public.
Mhm.
And so one of the terms in our workbook this week was astrobiology. How would you describe that, and how do you use that in your job?
Astrobiology, it's funny. I actually didn't learn about astrobiology until last year when I started doing this particular job. But astrobiology is really an amazing discipline because it's very multidisciplinary. It includes a lot of different people, like engineers and scientists and geologists and biologists. And what it does is it seeks to answer three really big questions, and that's how does life begin and how does it evolve? It asks, are we alone? And does life exist beyond Earth? And it also asks, what's the future of life on Earth and in the space environment and beyond? So those are huge philosophical questions that most people are really interested in. So that's what I love about astrobiology is we're trying to tackle those really difficult questions.
Awesome. And so I know that as we all do, the world has kind of changed a bit in the past few months.
Yeah.
So if you were in your office normally, what would your day typically look like?
My day to day, it's not going to sound very exciting, but I have meetings. I have meetings. I maintain the website, and also a lot of my day is planning my tasks and my projects, and documenting my work, which is not exciting, but it's important because if I get hit by a bus tomorrow, it's important for people to know what I was working on and how to move forward. The one thing that often gets overlooked, another thing that happens if I was in my office, is it's just the day-to-day interacting with people, actually being there, and even just running into people in the hallway. A quick 5-minute conversation could end up being a really huge deal later on. And it's those spontaneous interactions that we have that's really been impacted by the pandemic and not being able to do that. So although a lot of my job can be done remotely from home, which I'm very thankful for because I still have a job, but I am missing that part very much, and it drives me kind of crazy because I miss I like talking to people and being on the computer. It's great, get to see you, Elena, but I would rather be in person.
Yeah, that in-person brainstorming is just always
It
fun.
is. It's really helpful.
Yeah. So when scientists look for life beyond Earth, what steps or strategies do they use?
So a lot of scientists will look at the Earth, like the ancient and the modern Earth, because from that they could learn about all the different forms of life here and how life could leave certain clues or certain they call them biosignatures that indicate that it's here. For a long time, we didn't think life could exist in really extreme environments, but then in the 70s they started making these discoveries that there are actually life forms in extreme environments. So from the study of Earth and using it as an analog to look for life, what we say as we know it, because this is the only example we have right now, then we could go into space and we look at things like gaseous biosignatures, and those are detected in the atmospheres of other planets. And we look at surface biosignatures, and that looks at life-induced changes based on the absorption and the reflection of light on the surface of the planet. And then we also look at temporal biosignatures, which are time dependent, the fluctuations in the gaseous surface biosignatures. So all of those things are ways that we could look, and it's a really complex process. And every time, each year we go on and we do research, we learn more and more about it. And where we may be going along one path, the research may say, oh, no, now we need to switch gears and go this way. So it's always a changing thing, which is the beauty of science, is the more you learn, then you could refine your assumptions and your knowledge.
Yeah, absolutely. Another question we had is, how do we find planets outside of our solar system?
So the planets outside of our solar system, those are called, we refer to them as exoplanets. And the way we could do that is we use telescopes. in the beginning, you know, we only used the ground-based telescopes, and because they're all over the world, we were able to find some. But really, the telescopes that are more helpful are the ones that are in space. And so Hubble Space Telescope is the one that's in orbit around Earth, and that's the largest one right now. And we gained a lot of knowledge from that. But Kepler was a really big success story, and Kepler is the one that, after years of operating, found that there are way more planets out there than stars, which we had no idea. And then James Webb Space Telescope is going to be launched next year, and it's going to be the largest, most powerful, most complex space telescope. Wow. So that's really exciting. Something to look forward to next year.
Definitely. I love it. So we have someone who said, I am 9 years old, so what should I do to be the first woman on Mars?
Oh, I'm so glad you want to go to Mars, number one. You know, by you asking that question, that's a really good first step, because it shows that you're confident enough to ask that type of question. My best advice for you is to focus on your goal and give it your very best. Everything you do towards it, give it your best, and don't let others discourage you, whatever you do, because there's going to be those people out there, and you just can't let that get in the way. Your education is going to be key, because nobody could take that from you. And then you look for programs that enhance not only your educational experience, but also being able to interact with different people, because no matter what job you do, that's going to be helpful, and that'll help lead you to success.
Awesome. Yeah, I hope whoever asked that question, I hope you do make it to Mars. That sounds like so much fun.
But make sure that we could send you there safely, though. Don't go, don't go unless we're ready.
So have you ever worked on a rocket that has been launched into space?
Well, I haven't worked on a rocket directly. I have worked on stuff that was sent up in a rocket. And another term you might use is expendable launch vehicles, the ELVs. That's what we refer to rockets.
Oh, awesome.
So a lot of satellites are sent up on rockets.
Very cool. Do you think people could live on the moon?
My personal belief is we need to do there has to be a lot of thought being put into how we could do that safely and sustainably. But I do believe if done right, it is possible.
Yeah, and also another question is, do you believe in UFOs?
Yes, I do. Now, so UFO is an identifiable flying object, right? So I don't know what it could be, because it's unidentified. So it could be a satellite that we can't identify or something. I mean, probably not. Satellites we could, but anyway, it's unidentifiable. I do believe in it, but as of what exactly that looks like, I have no idea.
Yeah. And then where do you see space exploration in 10 years?
I see the real possibility that we could be colonizing the moon and trying to use it as a stepping stone to go to Mars.
Yeah, that would be fun. And have you noticed any ways in the field of space science and exploration that it could improve so that more women and people from diverse backgrounds feel welcome?
The best way to make somebody feel welcome is to solicit input from them and to really value what they say, take it seriously. Because by doing that, everybody wants to contribute to the job, to the mission, to the goals, to the successes. And so if you give people that opportunity and you help them to make them feel like they're part of the team, that's the best thing you could do. And also, there should be a process in place. If you're going to say you value diversity and inclusion, there needs to be a process in place so that when somebody's not doing that, that there's a way to report it so that actions could be taken to address that type of behavior. Because that's another thing that happens in the workplace, is that the company will say all these grand gestures, oh, this is important to us, but then when it comes under attack, nothing's done. And so then to me, it feels like it's like empty words, right? So really, if you want people to stay, you need to show that they're important. Everybody wants to feel important to the job.
Yes, definitely. And what is a significant challenge you've had to overcome through your education or career?
My biggest challenge, again, because of my very visible disability, is overcoming people's, it's always having to prove myself based on people's biases about what I can and can't do. And in fact, people who don't know me, their initial reaction is, number one, I can't take care of myself, which is silly because I live by myself. And number two, they think I'm not as smart as they are. And that's really annoying too, because I'm not, I don't claim to be the smartest person in the world, but, get to know somebody first before making your judgments and assumptions. And so to me, it's kind of a constant battle, and no matter what I do, really.
Definitely. And if you could go back in time, what would you say to encourage your younger self when starting your career in STEM?
I would say no matter what, don't get discouraged by other people's opinions about you. Their negative, with their negative opinions about you. And also don't get discouraged by failures, because we are only human and people make mistakes and people are going to fail. But the important thing is that when these things happen, that you learn from it so you don't do it again. And if you've done that, then that'll get you to success.
Awesome. And one of our last questions, any advice or words of encouragement in this next generation of STEM professionals?
I would say my advice would be to, I guess it's going to sound corny, but perseverance is really important, because life, we have our goals, we have our ideas how we want our life to be, and life is always going to throw us these curveballs, whether it's somebody dying who's really important to you, or these other things totally out of your control. And so the key to success is to be resilient and to deal with your emotions about that, but also to stay focused and to not give up.
Awesome. Thank you so much, Dana. And
Mm-hmm.
to our audience, thank you for joining us today. We do have an awesome workbook that talks a little bit more about space exploration within a space agency, as well as
Great.
what astrobiology looks like and what it would take for creatures or animals to survive outside of Earth's awesome atmosphere. So it's a really good workbook.
I highly recommend anybody who's interested in those questions about astrobiology to go into it, because it's an amazing field.
Yeah, it's been fun. I've been new to the subject as well, so it's been really fun to learn. So,
yeah.
Well, that about wraps it up. So, everyone joining us, thank you so much. And Dana, thanks so much for joining us to be our Innovator of the Week. And everyone, thank you for joining Next Gen STEM.
Thank you.
Bye.
Bye-bye.